All right, this is section 4.5, and we're looking at how to find the determinant of a matrix. You're going to see I'm going to have two separate videos for this particular section, okay? So every square matrix has a number associated with it called its determinant, okay? So this implies that in order for you to find a determinant, the number of rows and the number of columns in your matrix have to be the same, okay? And there's a couple different notations to represent the determinant, okay? So normally you would put brackets around the elements of your matrix, right? Well, determinant, instead of using brackets, you put just straight lines, kind of like absolute value lines, okay? So if we're working with matrix A and I want its determinant, I could simply use this notation. Or a second way, we could write a DET followed by the matrix letter, okay? So the DET, of course, would be short for determinant, all right? Now, this video is really just showing you how to find determinants for 2x2 and 3x3 matrices. And then later on in some future lessons, we'll be seeing how we can use these determinants for some different applications, okay? So if you want to find a second order determinant, which really just means the determinant of a 2x2 matrix, there's a little formula that you would follow, okay? So let's say we're working with matrix A, and it has the following four elements, A, B, C, D, all right? Then the determinant for matrix A can be found by the following calculations. You would take element A, multiply it by element D, and then subtract that result by the product of element B and element C. All right, so you're simply just finding that product, and subtracting the second from the first. And that's going to result in your determinant, just a numerical value. Okay, really simple. All right, so a couple examples here. Notice over to the left here, the notation that I'm using, I have straight lines rather than brackets. All right, so that's my indication I'm being asked to find the determinant for this particular matrix, okay? So I simply would find this product. I would take 7 and multiply it by 2, and then subtract it by this product, 4 multiplied by -3. It's going to give me 14 plus 12, which is, of course, 26 for my determinant. Okay. In the second example, I'm using the other notation. So if I want to keep the brackets around the matrix, then I would need to put a DET in front of those to signify I'm trying to find the determinant. Okay. But same calculations. I would do 6 times 0 subtracted by 4 times -1, which is, of course, 0 plus 4, or 4. Okay. All right, so at this point, pause the video, go to practice 1, work through it yourself, and then check your work with mine. All right, now I want to talk about finding the determinant for a 3x3 matrix. So this is known as a third order determinant, and there's two methods. So in this video, I'm going to focus on the first method, which is expansion by minors. I'll save the second method for another video, okay? Expansion by minors requires us to know what a minor is. A minor of an element in your matrix is simply the determinant formed by deleting the row and column that that element is in. So every single element of a matrix has its own minor associated with it, okay? So let's demonstrate that. You got to think of this, it's going to be like a formula that you would use to find the determinant, okay? So let's say matrix A is 3 by 3 with the following elements. All right. Then to find the determinant of matrix A, I'm going to take the first row, first column element, which is A, and I'm going to multiply that by its minor. All right. Now, again, its minor is a determinant, and you would find it by eliminating the row and the column that element A is in. Now, notice what that leaves us with. It leaves us with E, F, H, and I. Okay. Then you're going to subtract it by element B. So that's the first row, second column element. Okay, let's see if I can select that. Yep. Select that. And you're going to multiply it by its minor, which would be getting rid of the first row, the second column. And that would leave you with D, F, G, I. All right. And then we will add element C multiplied by its minor, okay, which would be deleting the first row and the instead of the second column, it would be the third column that element C is in. So that leaves you with D, E, G, H. Okay. All right, now once you have this all set up, you would then have to find the value of the three determinants, multiply them each by the values of A, B, and C, and then perform the addition and the addition and the subtraction at the end in order to come up with your final numerical value. Okay. Now, one thing to really draw your attention to that students always kind of mess up is notice how right here I have subtraction in this formula, but then right here I have addition. So that's something to always watch out for. Okay, so let's apply this to example 2 here. All right. Notice the notation here. I'm using straight lines, so that's telling me to find the determinant of this matrix. Okay, so I'm going to start off by taking the first row, first column element, which is 1, and multiplying it by its minor. So if I get rid of here and here, that leaves me with -1, 3, -2, -3. Okay, then I would follow that with a subtraction. And I'll take the first row, second column element, which is 0, and multiply it by its minor. So get rid of the first row and the middle column there, and that leaves you with 2, 3, 4, -3. Follow that up with a plus sign, and then your first row, third column element, which is -1, multiplied by its minor, which would be deleting the first row and the third column, leaving you with 2, -1, 4, -2. Okay, so at this point, you find the value of these 3 2 by 2 determinants. Okay, and you would do that using this same approach that we did back here on the second order determinants. Okay, so that's going to lead me to the following. So you keep the 1, and then the product of -1 and -3 subtracted by the product of 3 and -2 is going to lead you to 9. Okay, and then -0 multiplied by the product of 2 and -3 subtracted by the product of 3 and 4, which is -18. And then plus -1, or you can just say -1 multiplied by the product of 2 and -2 subtracted by the product of -1 and 4. That's going to be 0. So in the end, this leads you to 9 minus 0 minus 0, or 9. Okay. Probably not the best example because you got all those zeros in there, but typically you'll have 3 numbers at that point to work with to then simplify down to this single value. And right there's your determinant. Okay. All right, so you get a chance to practice now yourself. Okay, pause the video, go to practice 2, and work through that on your own, and then check yours with mine.